What's good, YouTube? Cosmic with another video. Um, Today it's gonna be a different video. Today we're gonna be reverse engineering C# malware. So before we get into the video, please like and subscribe and all that. Here's the VMs I'm using, a bunch of snapshots, whatever, Remnux and Flare VM. So let's get into it. Yay! Different kind of content. So we'll be reversing this. It's not a binary, but we'll be reversing a DLL, C# DLL. So first off, I don't know if you guys want me to explain. Okay, I won't explain it. I won't bore you. Let's not make it a big video. But C# is incredibly easy to reverse engineer, believe it or not. There's lots of tools to do it, but today we're gonna be using DNS spy. So let's start with basic static analysis. Let's say we didn't know what this malware was. We didn't know what it was or what language it was written in. So we do some static analysis. So I'm opening up CMD. Let's open up Commander. There's lots of ways we could strings it, we could use floss, but I like using floss more because there's a lot of what do they call in Windows, parameters, or there's lots of options. I'm not gonna say there's a lot of options when using floss. What's the, it's called malwares, and we could direct that to, let's just say malware.txt. If we cat that, we get options, and as we said, it's easy to compare. But the telltale signs that this is actually .NET is, first, you can see Floss's output. It gave us that it is .NET binary. It does not attempt to deobfuscate any strings. That's the first sign. The second sign that I usually look for is MS Core Lib. And MS Core Lib is a series of .NET libraries that can be imported when building C# applications. It's dynamically assigned at runtime. It's probably here somewhere. If not, we'll use grep. But there's a lot like system.txt. There's a lot of things. Get the environment variable, that is a call if I'm not mistaken. Let's just use, is this thing on? Question mark? Oh, I wonder why. Could clear that so it's easier to read. We could clear malware.txt. We could grep for MS Core Lib just to make sure, and it's not there. That's is weird. If I say case insensitive, okay, but it should, yeah, but we know it's a C# application, but I'm pretty sure I did this before. Thingy, that is so weird that MS Core Lib is not there. But I digress. We know it's a C# application, so we can go and open DNS spy. And but it is, oh, it's not CORE, that's my bad. Lib, there it is, and there we get it in the output, so that's cool. We can open a file because we didn't actually, let's arm it actually, so it's easy. We arming our binary. We'll just take away the mals extension and make sure it's a DLL. We'll open that .crypt mals, and here's the fun part. So that looks like some, is it called namespaces? They call namespaces in C#, not libraries, but yeah, you get it. So in the embed.dll, you see it's called embed.dll for some reason, not for some reason. Instead of, the original name was malwares.cryptlib, but DNS spy, do you see how beautifully decompiled it is? It's actually really cool, but I digress. So we have two classes. We have crypto and we have malware. So this isn't of any importance to us. we'll go to the actual program. And as you can see, the namespace is, you saw some of those things in our floss output. So that is cool. So it just shows us that it further tells us. And if we, okay, let's read the code. Yeah. So looks like we have a byte array. It creates a 256 hash of power overwhelming. It's probably a string. If you want to know what that is, we could, let's do it. Let's cat I don't know if it's like Linux. Let me check. 256. Can I cat that and do I get it? Okay, you can't. But oh no, you don't have to pipe it to anything if I'm not mistaken. Malware.txt. Do I not have 256? Oh, 256 sum. My bad. To malware. I'm not on my normal keyboard. I got a new keyboard, so my apologies. And there we got the 256 hash. So I think if we can copy that, we might get the same hash, but it doesn't show us. But I digress. Let's get. So it looks like after it creates that, it gets a 256 sum from this power overwhelming string. Excuse me. It creates a new text, and it looks like it's creating a new stream reader. And basically, a stream reader means that it can read it from, we can get the text from memory. It won't put it like on our system or whatever. And then the base 64 encodes it, and then it gives us a base 64 encoded output after encrypting it. We decrypt, yeah. What is this? This is text. Okay. After we get that, it looks like it writes everything to our public directory. So it'll probably write is it not there? Oh, C uses public, my bad. So it'll probably write it here. And then it will write this text there. It will write this string text here, like the decrypted version, or not whatever, but like, yeah, you get me. I need to reverse engineering as well, and it's like so fun. I'm not gonna lie, but okay, I digress. String 2 looks like we're creating a new stream reader, but it's not decrypting from. I mean, it's not AES encrypted. It looks like it's just decrypting from base 64. I mean, we could, because it's a small string, I can copy it and we can go to our Flare VM. And I think you can also do this on Remnux, but I think I don't have pasting enabled. I don't know why Windows does it. Is it at settings? We could echo that text and base 64 decode it. You could see, looks like it's creating, looks like it's creating an object and calling ms build with that value. That's, what do they call it? Not a premonition. I forgot what they called it, but like, that's a hint to the future. I forgot what they called it. Okay, we write that to a file, and then we write string text.2 to embed it to that directory. Then we have a try and catch block. Looks like it's opening the registry with the current user, and it's opening this subkey, and then it's setting a value of embedded with it's setting an embedded value with the value of this embedded of the VBS script. Excuse me, I'm just a bit tired. And we're setting okay. And you must remember the malware create this. Remember, it's this thingy. Then if there's an exception or if there's an error, it will give us this. That is cool. So next thing to do is we can Let's actually run it. But it's a DLL. You can't click on a DLL, and you can't just click on a DLL and it works. That doesn't work that way. You need a program or some kind of file to run the DLL. So we can use run DLL dot 32 and point to that the malware thing, the crypt lib, but nothing's gonna happen because we didn't tell it which functions open. So if we wanted to, I hate this 32% keyboard because like there's no up buttons and I don't know the shortcut. I don't think the up shortcuts work at all. We'll put a comma and we know that it's embed. We can go back to our thingy, and if you see the function call, you want to execute this function, this embed. So if we do that, it will run, and you guys probably coded, but there's a embedded.xml, and if we go to documents, there's an embedded.vbs. So if we check the locations of where this malware saved the samples, you'll see that it's embedded. It's in public documents, the VBS, and this one is just in the public directory, the text. So what I do now is that I'd read. Let's actually open it in. Where's VS Code? VS Code. I don't think I gave this thing enough memory. I think I gave it like 8 gigs RAM. Okay, but it opens. Actually, let's leave that and let's go for, yeah, also because we saw those files, let's go to regedit actually to check the register. It's HK, and let's get this path. Where's the path? Software and run. We copy that, we paste that. We'll remove that. I'm not sure if I can do it double text. We'll just see. And as you can see, we have the embed with the VBS script as the data of the whatever it's called. So that further says that malware did run on our system. Oh, before that, this is a VM. Don't run it on your actual machine. Just for people that want to run it on. I think I'll leave the link in the description or something if you want to analyze it yourself as well. But let's go see what these things actually do now. Not XML document. No. Go check the VBS script. VBS is always interesting. Oh, how do you word it up? Not output, my bad. I'd like to word rap. I don't know how to word rap. Give me a second. I want you guys to see it properly. This is okay. It's LZ. Thank you. So here we see this XML file. This is the XML file in the registry that we saw. So it looks like we're creating a new stream and we're compressing it from this base64. So what we could do is we could decode this and decompress it again, or we could just get the value of this and read it, but it doesn't matter. Looks like it. That's all the base64. It starts from there. And then we compress that But then what caught my eye was this system reflection assembly thing. So basically, what this does, it loads programs into memory. It's a common TTP, and a lot of malware authors use it because you can just load. I have it on my other PC. Unfortunately, I made a program and I was playing around with it, but I digress. I think I might show it in another video if I'm not lazy to edit this one, or I might add it in this video. So, because we know that, excuse me, I don't want to waste your guys' time, so we won't decrypt all this because we practically know what it does now. So it's gonna load whatever this is into a program. It's gonna invoke a program and have it run, basically. And then if you check XML, I mean the VBS, we see that it's running MS build, and MS build is basically runs the DLLs or whatever, if I'm not mistaken. So if we wanted to run it, we could, because I know what the malware does, we could run Wireshark as well. And I have my Remnux host as we're gonna use inetsim as well. Let me actually turn on inetsim. So we'll get a call on this. Excuse me. So if we do run the VBS script, we saw what the VBS script does. Where's my code? It just passes the XML to MS build script and it runs. Those are the arguments. This is creates an object of a shell and whatever, creates a shell object. So if we click on, did my shit freeze? Okay. Click on VBS script. It basically runs. I mean, we can check here and we do get traffic. And if you check the DNS request, the domain says the DNS request. It tells us that it goes to SRV Master Chief Grand Emporium.local. And we can actually check my VM why is my IPv 2.15 question mark? But that is okay, I guess. It is super weird though, because I know it's .05. It's not on net, is it? I'm just checking something real quick. It's on net. I should be able to. It's supposed to be on the host adapter, isn't it? It's ipconfig. Disconnect the question mark. Okay, that's 0.0.4. If I go to the Remnux, I'll stop this. Continue without saving. Sorry for the troubleshooting. That's really weird. I don't know why Remnux picked up .0.0.5. Okay, we'll do that again. As you see, there's no traffic. Actually wanna do like this. Okay, that's cool. Why is Epic Games coming through? The hell? So if you run the VBS script, you'll see that we got output here, and it thinks we. Where's the DNS? There's actually so many DNS records, holy. Ten of 5. Oh, there it goes. From 1004. What? Yeah, from 1004. That's an IP address. I wonder why that one went through, though. If that's an IP, but it still went through. I'm not 100% sure if because it was using that. But yeah, that's a record. And if it did have access to this Master Chief or whatever, it's basically a C2 dropper. So your PC would basically be reaching a C2 server, and they'd be able to remotely access your server and all that. So that's pretty bad malware. So if you like the video and you like more reversing of malware, not just C sharp, I don't know what else, like actual common malware now, like and subscribe. How do I exit this thing? Oh, and obviously you guys know, um, always create snapshots for always create snapshots and always restore those shared snapshots. This is before running the malware, you restore it so it doesn't get persistent. And yeah, 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 yeah.